Hello, everybody. My name is Kseniia Buzko, and today I'm presenting our research paper called Generative Video Editing from Unconfident to Confident. Public speaking is a crucial skill that greatly impacts success in professional and personal domains. Confident body language enhances the speaker's message and improves audience engagement. Unconfident behaviors like crossing fingers or folding arms can undermine credibility, making confident gestures essential in video presentations. Traditional video editing tools such as Adobe Premiere Pro and Final Cut Pro are limited in altering specific behaviors. They handle basic edits but struggle with nuanced micro gestures that convey emotional states. Manual editing of these subtle movements is time consuming and impractical for most users, often leading to unnatural results over time. When typical generative AI models for video applies broad stylistic changes, like transforming a person into a robot or applying artistic filters, making them unsuitable for preserving the speaker's identity and natural demeanor. Therefore, we are introducing Confident, confidence fostering identity preserving dynamic transformer, a generative video editing method that detects unconfident microgestures in upper body movements and transforms them into confident ones while preserving the individual's appearance, natural voice, and behavioral traits. We started exploring the topic by asking a simple question. What defines unconfident and confident movements? Identifying these movements systematically proved challenging, which led us to creating a comprehensive dataset centered around microgestures, a key component that potentially represents confident and unconfident behaviors. This pursuit led to more questions. First, how many microgesture labels are needed to represent body language comprehensively? And of course, what size and quality of the dataset are necessary for training AI models to predict and analyze microgestures with high accuracy and reliability? Another significant question of our research is how to edit unconfident movements like rubbing eyes or crossing fingers or placing hands behind the back into their confident counterparts, like standing tall with an upright posture. And how we can make sure to preserve the individual's identity and natural appearance, as well as voice. As there are no existing datasets suitable for our focus domain, which is microgestures that are indicative of confidence and unconfidence during video presentations, we came up with our own microgesture dataset. This involved annotating a series of videos from the YouTube channel Cut, where individuals respond to various questions. So far, we have 38 different types of movements, like when someone holds something, stands with hands on hips, or folding their arms. As you can see on the videos, only the upper body of a person is shown, which replicates a natural video presentation setting. To enable the confident model to accurately detect unconfident gestures and convert them into confident counterparts, it was essential to categorize the microgestures in our dataset as either confident or confident categories. To achieve this, we leveraged ChatGPT, a large language model developed by OpenAI, to assist in the classification process. ChatGPT has been developed using extensive collections of general knowledge, allowing it to excel at interpreting body language and gestures. The prompt that we used for the classification of each microgesture was: I have a list of microgestures observed during public speaking presentations. For each action, please classify it as either a confident gesture or an unconfident gesture based on general body language interpretations. On the table, you can see an example of the provided classification by ChatGPT. From the classifications, it is clear that gestures involving open body language, an upright posture, and controlled movements, such as standing tall, hands behind the back, etc., are associated with confidence. In contrast, gestures involving self-touching, fidgeting, closed body language, or avoidance behaviors, such as crossing fingers, folding arms, are linked to a lack of confidence. In designing Confident, our primary objective was to enhance perceived confidence in video presentations by transforming unconfident gestures into confident ones while maintaining the speaker's identity. This involves addressing both visual and audio elements. So now I will go through the whole pipeline of our model. First, the input video is divided into confident and unconfident segments. This allows us to modify unconfident behaviors while leaving confident segments untouched. Also, to ensure smooth transitions and maintain coherence in the edited video, we perform speech alignment by synchronizing audio with video frames. Additionally, we enhance the speaker's delivery by identifying and removing filler words and disfluencies. In next step, we are extracting key points from confident parts to model confident gestures, with some key points serving as references for transformations and others for interpolating joins. In our model, we utilize two diffusion models, where a first model takes reference frame and key points from the frame connection step to generate a confident body movements, while a second model creates facial expressions and synchronizes lip movements, using zoomed-in face from the first frame and altered audio. Finally, the outputs from the diffusion models are aligned to produce a seamless transformed segment that blends with untouched parts. Moving on to the qualitative results of our whole confident model, where we aim to enhance confidence in video by transforming unconfident gestures into confident ones while maintaining the speaker's identity. Here we have an input video where we aim to transform the segment with arms on my hips into a confident movement using our model. The target key points for this transformation are also taken from the same video. In the resulted output video, you can see the transform movement generated by our model, blending with the confident segment. However, there are some noticeable issues, such as face jittering and changes in the background color palette. These are areas for further development. To evaluate our model's effectiveness, we compared the transformed unconfident segments produced by our model with the original confident segments, whose key points were used for the transformation. As shown in the table, the FVD score is significantly higher compared to the state-of-the-art model Animate Anyone, indicating room for improvement in the temporal coherence of our method. However, metrics like SSIM, PSNR, and LPIPS show competitive or even better results than Animate Anyone. These metrics evaluate frame-by-frame quality and do not fully capture the temporal aspects of video transformations, which explains why the difference in these scores is less pronounced. In conclusion, this paper introduces Confident, a generative video editing tool designed to enhance confidence in public speaking by transforming unconfident gestures into confident ones, while preserving the speaker's identity. Our contributions include a comprehensive microgesture dataset, a behavior-preserving generative model, and validation through experiments that demonstrate the confident ability in improving perceived confidence. Future developments may involve expanding the dataset, improving face alignment, color consistency, and transition smoothness. And after that, we can think about creating a real-time application. Thank you for your attention.